Okay, in this video we're going to be looking at climate change basics, focusing on what types of gases the science community thinks is involved in creating this idea of a greenhouse effect and increasing this overall climate temperature or global temperature change. Alright, get some basics out of the way. We've covered some of this information before, some of this information on the Earth's history and how it began. We know that the beginning of the Earth, the sun wasn't producing as much energy as it is now. It's about 70% of the current energy production from the sun. We know that around 4 billion years ago is when water formed on the planet. We know life began a little bit longer after that. We're looking at about 3 billion years ago for photosynthesis. We know that carbon dioxide and methane are going to be removed from the atmosphere when photosynthesis occurs. Carbon dioxide and methane to the three big greenhouse gases on the planet. Plants, especially trees, are very good at being carbon sinks, or these carbon storage containers, to where most of our carbon dioxide on the planet is going to be stored in our forests. We also know that the Earth has gone through many cycles of warming and cooling periods, and we know that the overall temperature of the planet is directly related to the energy input from the sun itself. We also know that the makeup of the surface of the Earth, that includes the land, the water, the ice, and the clouds, are going to have an impact on the amount of energy that is absorbed by our planet. We know that clouds and ice reflect the amount of energy from the sun, whereas water and the soil or the land of the planet are going to absorb energy from the sun. And as long as these two processes are equal, the amount of energy reflected by ice and clouds, and then the amount of energy absorbed by water and land, as long as they're equal, our temperature for the planet is going to remain relatively constant. However, if more energy from the sun is absorbed by area that is covered by water and land, and less of it is reflected by ice, because say there's less ice than usual, then we know that there's going to be an overall increase in the Earth's temperature. Vice versa, we know if there's more ice on the planet, less land and water exposure, then you have more energy being reflected, less energy being absorbed, then we have a temperature drop, overall temperature drop on the planet. Alright, now, our atmosphere is very good for a lot of different fundamental reasons, and one of those reasons is the fact that it has certain gases in the atmosphere that act as a greenhouse. Greenhouse is, if you remember, we've spoken of this in class, the way a greenhouse works, it allows the sun's radiation or the solar energy to enter, and then it helps trap that heat once it gets radiated back from inside the greenhouse. The heat is held trapped, or somewhat trapped inside that greenhouse, to keep temperatures higher, more conducive for a growing environment within a greenhouse. Well, there are certain gases within our atmosphere that act the same way. We know that nitrogen is the gas that makes up most of our atmosphere. We know it's about 79% of our atmosphere is nitrogen. The second most abundant gas is going to be oxygen. We know that it's about 20% found in our atmosphere, and then the other 1% is going to be made up of smaller traces of gases, some things like argon, some things like water vapor. Methane is going to be one. Carbon dioxide is going to be one. Those are going to be made up of the smaller 1%. Now, the way this arrangement works is very good, because 99% of our atmosphere is made up of non-greenhouse gases, which means it does not trap any excess heat. The small little 1% is what's there to help maintain the overall temperature of the planet. and retains some of that heat to where not all of it is radiated back out into space, and then once the Earth spins and the sun goes down, then during the night we have low temperature or large temperature drops. These greenhouse gases are there to help that from keep that from happening. Now, unfortunately, the whole science community is in agreement that says yes, carbon dioxide, big greenhouse gas, up there in the atmosphere to help retain some of this heat so it doesn't escape once it's radiated back from the surface of the Earth back out into the universe. It's retained here. That way, the temperatures are kept relatively constant and conducive for living arrangements on our planet. However, we have been able to monitor and keep record, and ever since the late 50s, early 60s, we've been noticing that there's been a big increase in the amount of carbon dioxide, the CO2, that's been put back into the atmosphere. The U.S. alone contributes about 25% of the world's total CO2 production back into the atmosphere, which that equates to about 6.5 billion metric tons of greenhouse gases that are put there annually. Now, the thing with carbon dioxide is it hangs out in the atmosphere for about 100 years before it gets used by other processes or eventually gets used up. It's got a lifespan, if you will, of 100 years. So think about all of that excess carbon dioxide that's put into the atmosphere, how long it's going to hang out before its lifespan is used up. This is going to cause what we've seen in videos and we've looked at in other places, this overall warming of the planet. Some places experience warming more than others. For example, Greenland, that we watched in that video. Greenland has had an 8-degree temperature increase over the last 15 years. Its temperature has gone up 8 degrees. Greenland is a very large ice sheet. There has been a lot of melting going on, and they say that if Greenland were to melt, we would see an average of 25 feet increase in our overall water levels from our oceans. Other places, not necessarily all linked to warming temperatures, but islands, places that are really close to sea level, that these islands are sinking, which means our water levels, for the most part, have been tied to increasing as a result of some of this. Droughts are very prevalent. Large bodies of water. Lake Chad, for example, that was mentioned in that video that we watched. Now, Lake Chad isn't disappearing exclusively because of global warming. However, that warmer temperatures are definitely aiding in the evaporation process. But Lake Chad is also disappearing because of overuse through irrigation. Pollutants, more active pollutants are in the atmosphere as a result of all this stuff. So we're looking at a lot of different things coming together to aid this overall temperature increase on our planet to have a major impact, or have this a major impact that it's having. So it's not all due to just warming temperatures. However, if you combine warming temperatures with overpopulation, with overuse of resources, you're getting to these major impacts that we're seeing. All right, we know that CO2 emissions are going to continue to increase. Remember, places like China. China is the #1 leader now. Other developing countries, they're going to want to catch up with us. China has surpassed us. Eventually, some of these larger countries probably will surpass us. I remember the production of CO2 comes from the burning of our fossil fuels, so the burning of coal and oil. Coal, 70% of electricity comes from coal use. Oil, our vehicles are going to be based solely on the consumption of oil, of petroleum. So this link to fossil fuel use and excess amount of carbon dioxide, these are directly tied together. That's why there's such big pushes on trying to reduce the amounts of these fossil fuels that are being used. Not only are these vast resources deplenishing because of overpopulation, but it's also the fact of what we are causing to happen as a result of using these.